Hello and welcome to my final year engineering project progress report. This year I've been doing my project with the new racing team in the area of driver training and ergonomics. If you haven't heard of New Racing before, just a little bit of background. New Racing is a student-run university team who design and build a formula-style race car to compete in a competition against other Australian and international universities annually. Unfortunately, this year, due to COVID, the team will be unable to field a car at the 2021 competition. However, within this video, I'll run you through the scope of my project and the progress that has been made, mainly prior to the lockdowns. The scope of my project is more difficult to lay out than perhaps your traditional new racing project, where the student designs and manufactures a certain component on the car. To simply summarize the main area of my scope, it would be to maximize the amount of points the team scores at the dynamic events at competition, which if you aren't familiar with Formula SAE, this is all the events where the driver is actually in the car driving. To achieve this, a level of driver performance was desired for 2021 that was higher than the team's previous benchmark performance in 2016. As you can see in the chart on the right, 2016 was by far the best performance by the team at the competition. My project involved developing and commissioning certain tools and programs to assist the driver. This included race data analysis using the team's Motec data logger, researching and commissioning new racing simulator software and hardware, track development both virtually in the simulator and also in real life at track days, and also designing several ergonomics components on the car. A large focus of 2021 was on the aspect of driver training. The team has historically seen that the years that we performed well at the competition were the years where we had the largest amount of driver time in the car. Often this has been an area that was neglected by the team, and it showed up at the competition. For example, in 2019 the team got disqualified from one of the events for going backwards around the course. This is a simple error which would not have been made if the drivers had the chance to practice beforehand. In 2021, a three-stage program was created for driver training, which can be seen on this slide. Stage 1, the driver recruitment and selection, would be from March to June. Stage 2, the driver events assigned, would occur before August, and the important stage of driver training and development was set to be from August to December, in preparation for the competition in the second week of December. Driver training would take on 4 different forms throughout the year. Unfortunately, while testing in the real car is clearly the most beneficial form of training, this is often not feasible on a regular basis. As such, other driver training methods would be used, such as driving virtually on the team's racing simulator or the full motion simulator at the team's new sponsor, Escape Zone. The team would also run go-kart sessions throughout the year, both from a driver training perspective, but also as a great team bonding opportunity. My background personally involves racing go-karts for the past 14 years, so this is something I was passionate about and considered to be a valuable driver training tool. The first stage of driver training would focus on recruiting and selecting the team of 5 to 6 drivers for competition. Formula SAE rules require a minimum of 4 drivers to compete. A detailed scoring system was set up, and driver training sessions held weekly from March through to June. An example of the scoring from one of these sessions can be seen in the image on the left. During stage 1, we had 21 members of the team attend these different driver training sessions. Lap time data was taken from each of the members who attended and used to create a detailed Excel scoring spreadsheet. The top 6 drivers at the end of this were selected to progress to stage 2 of the program. These drivers can be seen in the blue box. Drivers highlighted with red attended less than 3 events and were excluded from the overall results. These 6 drivers then participated in stage 2 of the driver training program. This involved more on-track testing time and testing in the simulator, with a higher amount of data analysis to determine which events at the competition best suited them, and who would be the reserve drivers for the team. Stage 3 unfortunately could not happen due to COVID. However, this would have involved each driver training in more detail in their selected event. For example, if Tom was selected for the endurance event, he would only train for this event. The chart here shows the relative performance of some of the drivers throughout the year. Their performance throughout the year was improving relative to each other, which was a good sign. As part of my project, I introduced and developed a number of tools to assist with driver training. I'll run you through each of these programs and tools now. A new racing simulator was introduced as part of my project in 2021. The team's previous simulator was built in 2015 in the shell of a previous chassis. It was excellent in terms of realism, however, it was also very heavy and large, which made it difficult to transport and store. The software and hardware which was used was also quite outdated and didn't provide much experience for driver training. The new simulator for 2021 would need to be durable, portable, lightweight, quick to set up and pack down, easy to store, and realistic. This combination of criteria lent itself more to a commercially available rig rather than designing and manufacturing a custom solution. Several options were considered for the racing simulator, with the best three evaluated in a multi-criteria decision matrix, as seen here. From this, option 3 was considered to be the best and was purchased for the team. Here you can see the team testing the new simulator rig at the start of the year. The team's virtual reality headset was used, however this did cause several team members to feel nauseous. The team also had the opportunity to do driver training with our new sponsor Escape Zone in 2021. This was a great opportunity to use a professional full motion simulator, which typically costs in excess of $50,000. It was important with the new simulator this year that software was introduced to allow the team to create its own custom tracks to test on. Racetrack Builder was chosen to create the tracks, which should then be driven in Assetto Corsa. KS Editor will be used as a conversion between the two. Racetrack Builder was purchased to model detailed versions of the team's real-life test tracks. A total of 9 tracks were modelled throughout the year, including Winton Raceway, where the annual competition is held, Sydney Motorsport Park, and Coffs Harbour Kart Club. You can see here a comparison of what the real-life and virtual tracks look like, as well as some examples of the tracks created in detail throughout the year. These tracks were driven on the Assetto Corsa Racing Simulator program. For the first half of the year, the team utilised the University of Canterbury's car model for its driver training. This was due to the difficulty in creating a car model, and this was not a first priority for the team. Canterbury's model was found to be very close to what is expected of the team's 2021 vehicle. Track layouts were able to be tested virtually before the team even tested in real life. This was part of the verification and validation approach of the team in 2021 and allowed for the safety and efficiency of the track to be tested virtually. This also allowed the team to compare the performance on the simulator with real life, which was very beneficial for driver training. Also implemented in 2021 was a strong focus on race data analysis. The team has had a Motec ADL2 data logger for many years, however perhaps hasn't used it to its full potential. Historically, the team has struggled to use data analysis, and has been very difficult to analyze as it had to be set up manually. A focus of my project this year was to implement a more data-driven approach to driver training, which involved extracting and analyzing this Motec data in a professional manner. To assist in this in 2021, I had the opportunity to have a chat with several race and data engineers in professional motorsport teams such as Gary Rogers Motorsport. This showed that the tools that New Racing has available are essentially the same as what is used on a national level. I also had the opportunity to study 2 online data analysis courses, which gave details on how to use many of the features of the Motec software to improve driver performance. In 2021, the team also had the addition of a GPS unit to the Motec data logger. This meant that the location of the car could be accurately tracked, and lap times could be recorded automatically. You can see in the top image how the car was tracked throughout one of our test days, even where it was pushed to be charged. The data was used both for driver data analysis and also for car performance and health. In 2021, we were able to compare data from the real car with data collected in the simulator, which was a first for the team. Here's some examples of how data analysis was used throughout the year. This example you can see in 2 data traces comparing the best laps of 2 drivers. Often when analysing this data, you would look for the biggest jumps in the variance channel, which is the top channel in this image. What you can see is that right near the end of the lap, the reference lap shown in the coloured line has a large drop in speed and loses time. This also correlates with when the trail brake switch is triggered, which effectively cuts the engine for a small amount of time. This information can then be relayed to the driver, and they may be able to adjust their driving to stop this from happening in the future. Here's another example of a lap overlay comparing 2 drivers around a hairpin corner. In this case, you can see that the reference lap driver is braking 3 to 4 meters later into the corner, so it's gaining speed into the corner, however is losing speed out of the corner. This graph shows a scatter plot of the lateral and longitudinal g-forces in the car. This can be used for driver training or car performance when new components such as the aero kit are added. Another tool we can use in the Motec data analysis software is track mapping. What we can do here is effectively map any log channel around a lap. For example, here you can see the speed mapped, where you have the green in the fast sections and the red in the slow corners. Mostly in 2021, data analysis is used for driver training. However, it can also be used for monitoring the car health and performance. For example, here you can see the motor RPM and temperature data overlaid between two laps on the same day. What we can observe here is a difference of 30 degrees in the motor temperature between the two laps. What this caused was a loss of power out of the slow speed corners due to the motor overheating. This was observed by our drivers and also able to be verified on the data. Optimum Lap, another program the team has used previously, works out the theoretical best performance of the car around a given track. Part of my project was to improve the Optimum Lap usability given the GPS data. This allowed us to input the track data in a much more efficient manner. As you can see, last year's approach involved creating a crazy looking sketch in Creo. From this Optimum Lap output, we were able to see that our drivers were extracting close to the maximum performance of the car. It was also important to validate the data against each other. These images are a comparison on one of our test tracks, in Optimum Lap, real life, and our virtual simulator. The speed mapping between all three is incredibly similar, showing that each tool could be used independently of each other reliably. My scope also included designing several ergonomics components on EB3. These included the headrest, seat, and driver's harness mounting system. Some of the regulations around these safety systems were understandably very strict, which made designing these components a challenge. Here you can see the driver restraint system I designed, improving upon EV2's design. This design was analysed using a finite element analysis approach to ensure it could support the required loads. A jig was designed and 3D printed to ensure that it could be accurately welded to the chassis. The seat was determined to be an expandable foam seat insert, based upon our largest driver. The expandable foam needed to have some nice support to sit against, so an aluminium seat bucket was designed, which can be seen in these images. This would be laser cut and bent. The harness mounting system was comprised primarily of these two eye bolts you can see, mounted directly to the chassis. Many different mounting methods were considered, however, this was determined to be the most ideal. The red supporting tubes you can see were considered, however were not required by the rules. The second half of my project was significantly impacted by the COVID restrictions, unfortunately. This year's car could not be completed, and therefore no track data could be collected, which is effectively the largest area of my project. However, a strong base is set up for next year's team to perform well at the 2022 competition. It was important that the knowledge I had learnt throughout the year was transferred onto next year's team. To do this, I will be creating a YouTube tutorial series which effectively gets new team members up to speed on everything driver training related. Several sessions were held for younger engineers throughout the year to get them enthusiastic and learn about driver training. You can see here one of these sessions where one of the students is driving on the simulator while the others watch on. 2021, from my perspective, was about building a benchmark for next year's team, and I believe that this was able to be achieved. Well, that's all I can fit in a short video about my final year project. Thanks for tuning in. If you have any questions about my project, just chuck them down in the comments and I can hopefully answer them. Or you can tune in on the 12th of November for my FYP Part B conference. Thanks.